Hello guys, welcome back to our lab. So today we will continue with the second part of our lab MP-BGP, EVPN, VXLAN. In the first part, we established layer 2 VXLAN overlay. Today objectives will be to establish the communication between VNI 10110 and 10120. So let's start. So I'm going first to do some basic connectivity tests just to ensure that the lab is still stable, because since the last lab I didn't have the time to check it. So from PC1, I'm going to ping for C1 PC1, I'm going to ping 172.16.1.2. Great, okay. Also, dot code. Also from C2 PC1, I'm going to ping 172.16.2.2. Great. So going back to C1 PC1, so I'm going to ping 172.16.2.2 located on another VNI. Wait for the feedback. Okay, not working, so this is a normal behavior. So what we are going to do now is to configure our VTEPs to that so that we can be able from VNI 10110 to reach 10112, vice versa. So I'm going to connect to all VTEPs. VTEP 2, VTEP 3, VTEP 4. Okay, so let me close this. No need it. No need it. Okay, right. So right credential. Okay, cool. So since I'm going to push the same configuration on all three tabs, so I'm using multi-Excel mode so we can be quick. Okay, so the first step will be to create a VLAN. So let's call this VLAN, give it an ID 1020. Associate EVN, let's call this VNR 1021.2. So you can use whatever number you want because we have 60 million. But the best practice is to use a number that can help you to identify the customer ID, but also the VLAN associated with the VN. This is the first step. The second step will be to create a VRF. Let's call it customer one, and we will associate the VNI we have just created and generate the root distinguisher. So the RD or root distinguisher will be auto-generated by the system. So it will be a combination of the router ID and an internal system generated number. So onto address family IPv4 unicast, root target both auto, root target both auto EVPN. So I have this code manually twice because the main difference is the first root target will generate prefix root and the second root target will generate host root. So we need host root for load to EVPN also. So the first step will be to create an SVI for this VLAN. So interface VLAN 1020 associate with the VRF customer one. So we will not assign the IP address on this interface, but we just enable the IP forward. Okay. Next, we will create SVI for our customer. So we'll create SVI for VLAN 10 and for VLAN 20. So here in live tree. So live tree don't need VLAN 20. So I have to leave the multi-XA mode. So VLAN 10 interface VLAN 10, VRF number, customer 1, okay, IP address 172.1.254/24, no shutdown. So since this IP will be shared by all VTEPs, so we have to configure this interface as any cast KOA. So the command is fabric forwarding mode, any cast KOA. Okay, no problem. So we have the message that any cast gateway MAC is not configured. So we have to configure the any cast gateway MAC address so that it will be used with any cast gateway IP. So I'm going first to configure the SVI for VLAN 20, sheriff member, customer 1, IP address 170.16.2.254.24, no shutdown, fabric forwarding mode any cast gateway. And for global config, I'm going to create fabric forwarding any gateway MAC 004.004.004. So you can use whatever MAC address you want, but the MAC address should be the same on all VTAPs. Cool. And the final step will be not the final, but the final step or the global config will be to associate our just newly created VNI to the NVE interface or the tunnel interface. We will add new member VNI, then 21 to associate GRF. Cool. Okay. So for Lab2 is associated with the VNI 10.0.1.1.0. So we create interface VLAN 10, GRF member, customer 1, IP address, the same IP for VLAN 10/24, no shutdown, fabric forwarding more any gateway. Okay, no problem. Fabric forwarding any gateway MAC 0004.0004.0004. Cool. Because if you didn't configure this interface as any gateway interface, since all VTEPs are sharing is like connected to the same VLAN or the same or same switch, the switch will detect a duplicate address. So finally going to tunnel interface, associate VNI 10.21 to associate VRF. Cool. And for VRF 3, we have interface VLAN 20, VRF member, customer 1, IP address 172.16.2.254/24, no shutdown, fabric forwarding any fabric forwarding more any gateway. Okay, fabric forwarding any gateway mark 0004.0004.0004. Great, cool. And for the tunnel interface, we will add a member VNI 10.21 to associate GRF. And the last one, interface VLAN 10, GRF member, customer 1, IP address 172.16.1.254. slash 24 or shutdown. Fabric forwarding mode any car gateway. Fabric forwarding any car mode 0004.0004.0004. Okay, so now the next step will be already configure what you data show card interface VLAN 10. Oh, you did it, take it, my friends. Interface VLAN 10 fabric forwarding mode any car gateway. So you can notice that the system detects conflicts because they are all VTAPs are synced as connected to the same switch. Also, tray interface VLAN 20 fabric forwarding mode any car gateway. We didn't take the combined in consideration. Interface VLAN 10 fabric forwarding mode any car gateway. And here interface VLAN 10 fabric forwarding mode any car gateway. Also for interface 20 fabric forwarding mode any car gateway. Okay, cool. So the last step will be to configure the BGP so that we can advertise our prefixes. Router BGP 65000 VRF customer 1 address family IPv4 unicast network 172.16.1.0/24 and 2. Okay, cool. The configuration finish for leaf 1, for leaf 2, the BGP 65000 VRF customer 1 address family IPv4 unicast network 172.16.1.0/24 curriculum start config tray router BGP VRF customer 1 address family IPv4 unicast network 170.16.2.0/24 copy run start. And the lastly router BGP 65000 VRF customer 1 address family IPv4 unicast network was 2.16.1.0/24. So for now, if everything is fine, it should be okay. So from where still seeing, I know it's already good. Okay, so let us check now the L2 VPN table. Oh, share some good news. We are learning top 5 routes. That's good. Okay, but this is self. Okay, so show BGP L2 EVPN. Okay, this is self-generated. So let us just do this. Going to connect to C1 PC1. So from this PC, from 1.1, I'm going to ping 2.2. So normally if everything is okay, it should work. So ping 172.16.2.2. Go, 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 go. Wow. Come on. What is wrong? Four, three. Sure. Something's not good there. Okay, 20, verify. Okay, good. Interface one. IP address, already know. Customer one, okay. Okay. Interface VLAN 1020 is not enabled. Okay. Interface VLAN 1020, no shutdown. So I think I have also to check already. Just to be sure. Sure. Yes, it's the case. Okay. Interface VLAN 1020, no shutdown. Okay. Interface VLAN 1020, no shutdown. And interface VLAN up 1020, no shutdown. Cool. So let me back here and check show BGP L2 VPN EVPN. Cool. Yeah. So now you can see that uploading a tab file from .2 .3. So it's fine. So uh, cross the finger, should work. Yes. So it's fine. Cool, cool. So now we have inter-VXLAN communication between VNI 10110 and 10120. So let me also test from, for example, from from this one. Okay, so ping 172.16.1.1. Cool. It's working. Also, the two. Okay, working. The time to send RP request. And dot three. Go. So I have to check this host. Maybe it's not connected. Don't know the IP address. All things configured correctly. So I have to thank you for your time. So don't hesitate to ask the question or give some suggestion or if you have some recommendation to do. So bye bye. See you on the next lab.